So in this video, I am going to explain about worksheet questions of solid state. So in this video also I have selected some important models. We will discuss one by one. First question. A solid has a structure in which W atoms are located at corners of cubic lattice, oxygen atoms at edge centers, and the sodium atom at body center. The formula of compound is. So first I will write position. So W atoms are located at corners. Next, oxygen atoms at edge centers. Next, sodium atom body center. So from this we have to find formula of given structure. That means the sodium is present at body center means only one atom is present, body center atom. Next, O atoms are present at edge centers. So we have 12 edges. 12 edges means 12 into 1 by 4 contribution. Therefore, 3. Next, W atoms are located at corners. Corners means 8 corners will be there. 8 into 1 by 8 contribution. Therefore, 1. So, sodium atom 1. Therefore, formula is sodium 1. Next, W also 1 and O3. Or we can write NaWO3. So, option C. Simple question. So, here we have to take contributions. Corner contribution 1 by 8, edge center contribution 1 by 4, and body center means that belongs to whole cube. That means total atom belongs to that cube only. Next. If the length of body diagonal of face centered cubic is x angstrom units, the distance between two octahedral voids. That means we have to measure here shortest distance between two octahedral voids. So here I will write octahedral voids are located at body center and edge centers. These are location of octahedral voids. So distance between two octahedral voids will be equal to A by root 2. Remember this formula, A by root 2. Distance between two octahedral voids. Next. So here, length of body diagonal. Body diagonal root 3a. See, length of body diagonal is given x angstrom units. So from this we can find a equal to x by root 3 angstrom units. Therefore, distance between two octahedral voids equal to a by root 2. That is, a value is x by root 3 into root 2 angstrom units. So which is x by root 6 angstrom units. This is the answer. So option C. Next. A cubic edge length is given 1 centimeter is divided into smaller cubes of uniform size of length 1 nanometer. Assuming that no voids are present, the ratio of total surface area of all cubes of 1 nanometer edge length to surface area of initial cube is. So here, first surface area of large cube, initial cube, large cube equal to here 1 centimeter square, or we can convert it into nanometers, 10 power 7 square nanometer square. This is surface area of large cube. So it is divided into small cubes of length 1 nanometer, and the surface area of small cube, which is equal to 1 nanometer, is given. That means 1 nanometer square. So therefore, from this we can find number of small cubes. Number of small cubes equal to, so volume of large cube by volume of small cube, which is equal to, the volume of large cube we can write 10 power 7 whole cube nanometer cube by 1 nanometer cube. Next, so that is simply 10 power 7 whole cube. So these are the number of cubes, small cubes. Next, surface area of, that means ratio of surface area equal to, so number of small cubes into surface area of small cubes by surface area of small cube divided by surface area of large cube. So which is equal to, so number of small cubes, so 10 power 7 cube into surface area of small cube 1 divided by 10 power 7 square. So which is equal to 10 power 7 is the ratio. So option B. Very, very important question. Next. Iron crystallizes in FCC with edge length 400 picometers if it contains 0.1% Scotty defects. Calculate approximate density. Atomic weight is given 56. So next, for FCC is also known as CCP structure. So here edge length is given, edge length A 400 picometers. So we can convert it into grams per centimeters cube is 400 into 10 power minus 10, 10 power minus 2 minus 12 meters, that is 400 into 10 power minus 10 centimeters. Next. So effective number of atoms Z equal to 4 for FCC. Z is 4. Next. Atomic weight is given 56. We can take it as here M. Next. Here we must calculate density if it is 0.1% Scotty defects rate. Therefore, effective number of Z equal to 4 minus. So due to Scotty defect, density decreases. That means effective number of atoms also decreases. 4 minus 4 into 0.1 by 100. So that is equal to 3.996. So therefore, density D equal to Z into M by A cube into Na. So that is 3.996 into M means atomic weight, that is 56, by A value 400 into, so 10 power minus 8, A value 400 into 10 power minus 10 cube into 6.022 into 10 power 23. So therefore, density will be equal to, by solving, we will get 5.8 grams per centimeter cube. 5.8 is the answer, option A. The next question. The fraction of total volume occupied by atoms in simple cubic structure. So for simple cubic, or primitive cell, so effective number of atoms equal to 1. That is 1 atom per unit cell. 1 unit cell of simple cubic structure contains effective number of atoms 1. So therefore, volume of simple cube equal to the number of atoms into 4 by 3 pi r cube. Therefore, packing efficiency or packing fraction equal to volume of atoms by, let's see, volume of atoms by volume of simple cubic structure. Packing fraction is just ratio. So volume of atoms 1 into 4 by 3 pi r cube by volume of simple cubic. If edge length is, say, edge length equal to A, then it becomes A cube. Therefore, packing fraction equal to 4 by 3 pi r cube by, so A value is 2r for simple cubic, 2r cube. 4 pi by 3, r cube cancel, divided by 2 cube, 8. That means pi by 6. It is the fraction. Fraction of total volume occupied by atoms in simple cubic. So since A equal to 2r for simple cubic. Option C. Next. A compound made up of two elements A and B. The general formula AXBY, where B atoms form HCP lattice and A occupies 2/3 of tetrahedral voids. Formula of compound. Very, very important. So here B atoms form HCP. So for HCP, effective number of atoms equal to 6. Effective number of atoms. Effective number of atoms. So how to calculate effective number means HCP lattice. So 12 atoms into 1 by 6 contribution. Next, 2 atoms space centers plus 3 atoms body center. Therefore, 2 plus 1 plus 3, 6 atoms. 6 atoms per unit cell. So, B atoms will be 6. Next, number of tetrahedral voids equal to 2 into Z. That means 2 into 6, 12. Next, therefore, formula we can write B atoms are 6 and A atoms 12 into 2 by 3. That is equal to A, A8, B6, or we can write A4, B3. This is the formula. Option C. So A atoms occupy 2/3 of tetrahedral voids. A tetrahedral voids 12, 12 into 2 by 3. So B atoms are 6. Therefore A4, B3 is the formula. Next, the angle between these two planes. These are coordinates. So angle is cos phi equal to h1 h2 plus k1 k2 plus l1 l2 divided by root of h1 square plus k1 square l1 square into root of h2 square k2 square l2 square. So here given points are 1 0 0. So this is h1 k1 l1 and 1 1 0 h2 k2 and l2. So therefore cos phi angle is, so 1 into 1 plus 0 into 1 plus 0 into 0 divided by root of 1 square plus 0 square plus 0 square 1 square plus 1 square plus 0 square. So therefore finally cos phi value will be equal to 1 by root 2. That implies 1 by root 2 is possible when angle is 45 degrees. Option C is angle between two planes with coordinates 1 0 0 1 1 0. Next, so one formula is given: Li, CO and O2 crystallizes in rhombohedral structure. Consider a situation where 50% of lithium is extracted from the lattice to keep crystal electrically neutral. Change in average oxidation state of cobalt is. So lithium, cobalt and oxygen are present. So given Li, CO and O2 are given. So we know Li will be in +1 state, CO 3 plus common states, O 2 minus. These are normal oxidation states. Suppose 100 atoms are present. 100 atoms are present. present each. So therefore, you can write total charge will be equal to 100 into Li plus 100 into CO equal to 400. So 100 atoms present each. Then, so 100 atoms of lithium, 100 atoms of cobalt are present. 100 into plus 1. Next 100 into plus 3. Total 400 total positive charge. This is total positive. Next. After extracting 50% of lithium, after removing 50% of lithium, comma, the total charge becomes total charge becomes 50 into Li plus 100 into CO will be equal to, this total becomes 400. So from this, next 50 into Li, that means 50 into plus 1, 100 into plus 3. So therefore, 100 into CO equal to 400 minus 50. So which is 350. So therefore, CO equal to 3.5. So this is new oxidation state. So initial oxidation state of cobalt is plus 3. Final oxidation state is 3.5. So therefore, percentage increase in oxidation state equal to 3.5 minus 3 by initial value 3 into 100. So its value 16.66%. See once again, LiCOO2 is given. In that Li oxidation state plus 1, CO oxidation state plus 3, O minus 2. So if 100 atoms are each is present, so Li 100 into Li plus 100 CO equal to 400 total positive charge. After removing 50% of Li, new oxidation state of cobalt becomes 3.5. Initial 3. Therefore, 16.66% of increase in oxidation state is present. That means option B. Next. How many of the following show ferrimagnetism? Ferrimagnetism. Ferrimagnetism Fe3O4. So this can be written as Fe Fe2O4. Next Mg Fe2O4 and Ni Fe2O4. These are similar compounds. So these can show ferrimagnetism. General formula. So like B2O4 like this. General formula will be. General formula. Next, remaining compounds. So CO2 is not CO2, CrO2. CrO2 is ferromagnetic. Next, MnO is antiferromagnetic. Therefore, three compounds can show ferrimagnetism. So all these are known as ferrites. Ferrites. So option C. That means three compounds can show ferrimagnetism. Next, a simple question. So ferromagnetism alignment of electrons only in one direction. So antiferro equal number of upward and downward. Next, ferrimagnetism unequal number. Unequal number. Check here. Unequal number of upward and downward. So therefore option. So for A2 antiferro, one upward, one downward. Next for B, ferromagnetism, all are in same direction. Next for C, unequal number of upward and downward. Therefore option C. Option C. A2, B1, C3. So very important. Alignment of electrons. Next. The packing efficiency of simple cubic, body centered and cubic closed packing lattice. So for simple cubic packing efficiency, 52.4%. Next FCC or CCP. FCC or CCP 74%. Next BCC body centered cubic 68%. Therefore CCP highest, after that BCC, next simple cubic, option D. Packing efficiency. Next, the crystal structure of an element has FCC lattice. So edge length is 4 angstrom units. So what is the atomic weight of that element? Density is given 11.21 grams per centimeter cube. Grams per centimeter cube. Grams per. So Na is 6.023 into 10 power 23. So from this we can calculate atomic weight. So for FCC, effective number of atoms equal to 4, Next, A is given. A is 4 angstrom units. That is 4 into 10 power minus 8 centimeters. So from this we can calculate D equal to Z into M by A cube into Na. So from this M equal to D into A cube into Na by Z. Therefore M equal to, so density 11.21 into A cube 4 into 10 power minus 8 whole cube into Na 6.023 into 10 power 23 divided by effective number of atoms 4. So you'll get atomic mass or atomic weight as 108 grams per mole. So option C. Next. Which of the following statement is not correct? So packing efficiency of HCP and packing efficiency of CCP are given. So for HCP, packing efficiency is 74%. Next, for CCP or FCC, packing efficiency 74%. Both are same. So which is not correct, they are asking. Not correct. Check option B. Option B. Packing efficiency of FCC greater than packing efficiency of CCP is given. That is wrong. So both are identical. Identical. Very, very important. Next. Next one. Check next question. The anion Ca of this molecule, your molecule is given Cp and Aq. So anions can form FCC lattice. Anion means A. A anion and C cation. So anions form FCC or CCP lattice. So therefore effective number of atoms 4. Next, cations occupy, here cation C are positioned at body center and half of the edge centers. So a body center means 1 atom plus half of edge centers. So edges 12 will be there, half means 6. 6 into 1 by 4, that is 1 plus 3 by 2. So total 5 by 2. So therefore formula is, so cation 5 by 2, anion 4, or we can write C5 A8. C5 A8. D is the option. So anion forms FCC or CCP. Therefore effective number of atoms 4. Cations occupy body center, that means 1 plus half of edge centers. Edge centers means, edges means 12 will be there. In that half 6. 6 into contribution 1 by 4. C5A8 is the formula. Next. Very, very important. So you're matching Frenkel defect, Scotty defect, vacancy defect and metal deficiency defect. So Frenkel defect will be exhibited by compounds with low coordination number. Low coordination number means here AgCl, which is 3. Next, B. Scotty defect will be exhibited by compounds with higher coordination number. Higher coordination number means NaCl, which is option 2. Ski. Vacancy. Vacancy defect will be exhibited by crystal with vacancies. Therefore, option 4. Next, D. Metal deficiency. Metal deficiency, FeO, that is 1. Therefore, 3, 2, 4, 1. So, option B. 3, 2, 4, 1. Option B. Next. Number of network solids and ionic solids in the given examples. So, first I will write ionic solids. Ionic solids are here what are given. So H2O, Aln, Cu, CaF2, diamond, MgO, CCl4, ZnS, Ag, NaCl and SiO2. So here NaCl is ionic we know. Next CaF2, calcium fluoride, MgO and ZnS, ionic solids. Next, ionic solids 1, 2, 3, 4. Next, network solids. Network solids. Network solids are diamond. Next, SiO2, silica, Aln. That means here 4 and 3. Next, metallic solids are there here. Metallic solids. So what are metals? Cu and Ag. Next, hydrogen bonded molecular solids. H2O ice. So here they are asking about network solids and ionic solids. Network solids 3, ionic solids 4. 3 and 4. Therefore option B. B. Next. So iron exhibits BCC structure at room temperature. Above 500, it will be converted to FCC structure when the ratio of density of iron at room temperature to at 500 degrees centigrade. So assume atomic radii and molar mass of iron remains constant even at high temperature. So ratio we should find. Next, that means so density formula Z into M by A cube into Na. Next, first for BCC, effective number of atoms 2. Next, A equal to 4R by root 3, edge length. Next, for FCC, Z equal to 4, effective number of atoms 4, and A equal to 2 root 2 R. 2 root 2 R. So therefore, ratio of density. So density of first is BCC, density of BCC by density of FCC equal to, so 2 into M is constant by 4R by root 3 cube into Na, so divided by 4 into m by 2 root 2 r cube into Na. So this will be the ratio complete. Na constant and m is also constant. So from this we'll get 3 root 3 by 4 root 2. So therefore ratio is 3 root 3, 4 root 2. Option A. Simple one. Just substitution only. Next. Calculate coordination number of Na plus in NaCl crystal given Na plus Cl minus radii. So radius ratio equal to radius of cation by radius of anion. So cation 95 by anion 181. So this value 0.525. So which is in between 0.414 to 0.732. So this corresponds to, therefore coordination number is 6. This radius will be for octahedral. So obtained value is in the range of 0.414 to 0.732. Therefore octahedral. Coordination number 6. Option C. Next. The radius of an atom of an element which forms body-centered cubic is 173.2 picometers. Volume is given by. It is given radius. So for BCC, radius is given 173.2 picometers. We should find volume in centimeter cube. Therefore, convert it into 1.732 into 10 power minus 8 centimeters. So for BCC, we know 4R equal to root 3A. So from this A equal to 4R by root 3. That is 4 into R value 173. It means 1.732, not 173. 1.732 into 10 power minus 8 by root 3 value 1.732. Therefore, A is 4 into 10 power minus 8 centimeters. So from this volume, therefore, volume of unit cell equal to A cube. 4 into 10 power minus 8 cube. That is 64 into 10 power minus 24 or 6.4 into 10 power minus 23 centimeter cube. For option B. So radius to volume. Very, very important. Next. So total number of body-centered lattices possible among 14 Bravais lattices. So body-centered cubic is present in simple cubic, that means cubic system, tetragonal system and orthorhombic. So in these three systems, BCC is present. Therefore, option 3. Simple cubic, tetragonal and orthorhombic structures BCC is present. Next. So, pure silicon doped with phosphorus is silicon doped with phosphorus, which is 5th A group. 5th A group means valency here 5. So therefore one extra electron will be present. So therefore it is N type. N type of semiconductor. Very important. N type. Negative charge. N means here negative. Extra electron will be there. So out of 5 electrons, 4 electrons will be involved in bonding and 1 electron will be free. Option C. Next. A metal crystallizes in body-centered cubic with metallic radius √3 angstrom units. Volume of unit cell is. So this is very important. So body-centered cubic is given. For body-centered cubic, A equal to 4R by √3 and volume equal to A cube, we know. So from this we can calculate, therefore volume equal to 4R by √3 whole cube. That means, so here radius is given as √3 into radius is given R value √3 into 10 power minus 8 centimeter cube or that means centimeters or √3 into 10 power minus 10 meters. So substitute these values. 4 into R value √3 into 10 power minus 10 divided by √3 whole cube. Therefore, volume equal to √3 gets cancelled. 4 into 10 power minus 10 whole cube, which is meter. 10 power minus 10 means meter cube. That is 64 into 10 power minus 30. Therefore, 6.4 into 64 into 10 power minus 30. 6.4 into 10 power minus 29. This is the answer. 6.4 should be there. So option C, 6.4 should be there here. You will write 6.4 into 10 power minus 29. Therefore, option C. Here also 6.4. Important model. 6.4 10 power minus 29. Volume meter cube. Very important. Next. So molecular solid. That means P. P molecular solid. Your molecule is 3. Next. Ionic solid MgO, MgO 4. So 3 means here H2O, 4 MgO ionic. Next, or metallic solid, which is Mg. Next, network solid is SiC, that is 1. Silicon carbide carborundum. Therefore, 3, 4, 2, 1. 3, 4, 2, 1, which is present in option D. Option D. Simple question only. Next. So, alkali metal halides do not show dislocation defect because alkali metal halides means we can take it as NaCl. Here cation Na plus, anion Cl minus. They do not show dislocation defect due to ions having similar size of cation and anion. They can show vacancy defect. So this can show vacancy defect, that is Scotty defect. They do not show dislocation defect. They can show vacancy defect. Here there will be missing of equal number of cations and anions from their lattice positions. Therefore option A. Due to similar size, they can show Scotty defect, which is vacancy defect. Next. How many number of atoms are there in cube based unit cell having one atom on each corner and two atoms on each body diagonal of cube? So this is very important. So here given one atom on each corner. Next, two atoms on each body diagonal. It is given. So one atom on each corner means, here I will write like this. So one atom on each corner. So we know corners will be 8. 8 into contribution 1 by 8, 1. So therefore effective number of atoms 1. Next, two atoms on each body diagonal. So we know body diagonals will be 4 into 2. Therefore 8 atoms. Four into 2, we'll write here 8 atoms. Therefore total number of atoms equal to 1 plus 8, 9. So one atom is on each corner. 8 corners will be there. 8 into 1 by 8 contribution, 1 atom. 2 atoms on each body diagonal. 4 body diagonals will be there. 4 into each body diagonal has 2 atoms. 4 into 2, 8. Therefore 1 plus 8, 9. Option B. Next. A metal crystallizes in BCC lattice with edge length 300 picometers. Density is given. Molar mass of the metal. Simply So for BCC Z equal to 2, effective number of atoms 2. Next, edge length is given A value 300 picometers. That means 300 into 10 power minus 10 centimeters. Next, from this we can write density equal to Z into M by A cube into Na. So from this M equal to M we should find D into A cube into Na by Z. Therefore M equal to density 6.15 into A cube, 300 into 10 power minus 10 cube into 6.022 into 10 power 23 by 2. Therefore M value equal to, we get 50. So 49.815, approximately 50 grams per mole. So 50 is the answer, option A. Direct question only. Next. So here one compound is given, chrysoberyl, which contains beryllium, aluminium and oxygen. The element beryllium, aluminium and oxygen. Next, oxides form CCP structure. So that means O can form FCC or CCP structure. Next, so CCP means Z equal to 4. Therefore, tetrahedral voids equal to 8 and octahedral voids equal to 4. Next, aluminium occupies 1/4 of tetrahedral voids. Aluminium occupies 1/4 of tetrahedral voids. Tetrahedral voids are 8. So 8 into 1 by 4. Next, beryllium occupies 1/4 of octahedral voids. Octahedral voids 4, 1 by 4. So therefore, Be1, Al2, O4 or Be Al2, O4 is the formula. Option B. Simple question. Very, very important. If effective number of atoms equal to Z, tetrahedral voids 2Z, octahedral voids Z. Next. A metal crystallizes in FCC with metallic radius. So volume we should find in meter cube. So for FCC, so we know A equal to 2 root 2 R. So R value, radius is given root 2 in R. So in meter cube means root 2 into 10 power minus 10 meters. So 1 angstrom unit equal to 10 power minus 10 meters. So therefore, volume of unit cell equal to A cube, that is 2 root 2 R whole cube, which is equal to, therefore volume of unit cell equal to 2 root 2 into R value root 2 into 10 power minus 10 meter cube, that is 4. That means 64 into 10 power minus 30 meter cube. Therefore, 6.4 into 10 power minus 29 meter cube. Option A. Next. So 1 mole of NaCl is doped with 10 power minus 5 moles of SrCl2. The number of cationic vacancies in crystal lattice will be. So SrCl2 can be written as Sr2 plus 2Cl minus. So NaCl is doped with SrCl2. That means 1 Sr2 plus will be equal to 1 cationic vacancy. So 1 Sr2 plus N can create 1 cationic vacancy. So therefore, number of Sr2 plus ions equal to, so 10 power minus 5 moles into 6.022 into 10 power 23. Therefore, that is equal to 6.022 into 10 power 18 ions. So therefore, number of cationic vacancies equal to number of Sr2 plus ions. That is equal to 6.022 into 10 power 18. Vacancies. The option A. So 1 Sr2 plus can displace 2 Na plus ions. That means one place of Na plus will be occupied by 1 Sr2 plus. Therefore, it can create one cationic vacancy. So number of Sr2 plus ions equal to number of cationic vacancies. Next. So which are the following is network crystalline solid. So I2 is molecular solid. NaCl ionic solid. Is also hydrogen bonded molecular solid, and ALN is network solid. Therefore, option B. Just example only. So this is the end of the chapter. In next video, I will explain one more chapter. So all the best and thank you.